Hello friends, this video is one of a series of videos I'm going to make about how to build a pool or an aquarium outside of the house in the garden to rear turtles, water turtles, using cheap materials or alternative materials. In this first chapter I'm going to talk about designing the pool or aquarium and selecting the materials we need, the cheapest materials. In the second chapter, I'm going to talk about making an external filter for this pool and also at the lowest possible cost. And in the third chapter, I will show you how to build this pool, an aquarium, using alternative materials, also at a very low cost. Okay. Let's start then with the design of our pool. We can make our pool with cement. We can seal it by painting it all over or fixing tiles on the inside of the pool. We can also use a plastic pool used for children, for example. We can make a pool made of glass or acrylic. But all these materials are very expensive, especially if we're talking about a pool about 300 liters or more. As I see it, our best options are the following. We can use a bathtub. An old bathtub we can buy in the market second-hand at a very low cost. In Chile you can find bathtubs in the market, second-hand market, for $30 or $40. I don't know in your country how it is, but probably you'll also find very cheap materials, maybe even for free. The important thing is that the inside surface of the bathtub mustn't be chipped. Another option is an old refrigerator thrown away as scrap. It's free, and if it's in good conditions, the plastic, the inside surface of the plastic isn't broken or anything like that, it can be very useful. Now, ideally, it should be a fridge of only one hole. A cooler would be a good option. Now, if you only find a fridge that it's cut in two parts, divided in two parts, well, you have to find a way to put those two parts together so we can use the whole space inside the fridge. Now, the advantages of a bathtub are the following. Although it's not free, it can be found at a very low cost. We don't need to open a water outlet because a bathtub already has the hole there. The metal of a bathtub adheres very well with silicone, so we can seal any necessary place very easily. A bathtub is designed to hold many hundreds of liters of water. Which are the disadvantages of a bathtub? The metal of a bathtub transfers heat or cold very easily, so it is very dependent on environmental temperature. If you need to make an outlet on the side of the bathtub, then it gets kind of complicated because you can ruin the inside surface of the tub. And a bathtub will require much more material to lift it above the ground at the level we need it to be. Which are the advantages of a refrigerator? First of all, we can find them for free. The walls of a fridge are full of insulation to stop the cold from getting out or the heat from getting in. And that is very useful for an aquarium because it makes it independent of the outside temperatures. A refrigerator requires less material to get it to the height we need it because the refrigerator is supported from underneath, not from on top like in the bathtub. And if you need to make a hole in the refrigerator, it's very easy. The materials are soft, are thin, and easy to get through, and you won't ruin the inner surface of the fridge. Additionally, the interior space of a fridge can be much bigger. The volume of water we can put in a fridge can be much larger than the volume of a bathtub. Now, which are the disadvantages of a fridge? The HIPS polystyrene plastic might not be very easy to stick to bond using silicone or any other adhesive in case we need to cover holes or cracks or when making a hole and putting an outlet for the water. A fridge is not designed to hold hundreds of liters of water inside it. So there's always a risk that the plastic might warp and deform or even crack due to the excess weight it's holding inside it. In this project, I'm going to try and make a pool or an aquarium using an old refrigerator. The details and explanations of how I'm building this will be explained in chapter 3. A turtle pond or aquarium also needs a good water pump and an external filter, a set of filters inside a box. The details of how I prepare this filter, how I build it, will come in chapter 2. But now I want to talk to you about the water pump. So we don't have to spend too much money on a water pump. We can always get a water pump for free, getting it out of an old washing machine. I've found many water pumps in washing machines and they work fine. The only thing that different washing machines have different water pumps. Some water pumps have the entry coming in horizontal and going off horizontal. Or they come in horizontal and go off vertical. Or they go off vertical down. They're not all the same. And sometimes even the diameter of the tubing is different. Now, these water pumps are very low in energy, 30 or 40 watts at most. So they aren't expensive when running them. And by rules, they have to lift the water 1 meter high, at least. Some of these pumps are capable of lifting the water above 2.5 meters, or 8 feet if you want. The only issue we have with these pumps taken out of washing machines is we have to verify that they're working properly. First of all, we can connect it to electricity and see that it turns, that it activates. Second of all, we should connect it to a system like this one. We have to fill it up to level with water, marking that level, and we must know how much water there is between that level and the entrance of the tubing to the pump. Once we connect the pump here, we connect another tube where the water is pushed out, is pushed up to level above 1 meter. Then we take the time between the moment we start the motor, the pump, and the water is removed up to this level before it gets to the level of the tube that goes into the pump. With this information, the amount of liters of water and the time it took in removing all that water, we can define the amount of liters or gallons per minute of the pump. That gives us an idea of how good the pump is. Also, if the pump is capable of removing all the water above 1 meter, it should be more than enough for what we need, at least for this project. Maybe in your project you'll have to do something different, but in this one we need just 1 meter high. Now, what problems can we have here? If the rotor of this pump is worn or damaged, it won't be able to push the water as fast or as high as we need it. So here we can test the pump with this system. Okay, here in the container we have a whole 10 liters in total, and subtracting the 3 liters that are at the level of the pump, 7 liters is what I'm going to remove with the pump and take the time for that. Now, I have a small leak here. I just hope that when the pump starts off it will remove that joint. because I haven't stuck it together. But let's see what happens. Well, I've tried this 2 times already, and both times it's so powerful, this little pump, that it blows these connections, throws them about. The water pulls the connections off all the joints, and those joints, I've got them stuck there with silicone, but that's not enough. It just blows them off. I would have to stick this with special glue for PVC, which I don't want to do because I'll just lose those joints, and I need them. So I'll just make it work, remove the water from the container, just for you to see how powerful it is. And that's it. Now I know that this pump is really working well. It's very powerful, and all I need to do is fix those pipes well so it'll work in the aquarium. The other important factor in the design of this pool or aquarium is the location of the outlet that takes the water from the pool or aquarium to the filter and the pump. In a bathtub we only have one option, unless we want to make a hole in some part of the tub, which would be a risk of damaging the surface and the tub. So in general we would put our water outlet here, where it's already built into the tub. In a bathtub the outlet is at the bottom, and we must put the bathtub above the filter, so that the water comes out of the outlet, falls as a spray by gravity onto the filters. This spray is important so that the water picks up oxygen on his way back into the pool. The oxygen in the water is very important for the nitrifying bacteria that we are growing here in our filters, because these nitrifying bacteria will convert the ammonia of the pee of the turtles into nitrates. That is useful for our plants, and it is not toxic for our turtles. So, for this reason, we have to build a table about 80 centimeters high to be able to hold the bathtub above the filter box. If this was a refrigerator, the refrigerator is supported at the bottom, not at the top. So we only need a base, a table of 40 centimeters high, and that means less material, less expense. And even still, in this case, this refrigerator has 2 spaces, one small one here and a bigger one over here, that I'm going to cut open to have them communicated. But even if they are communicated, we still have to have 2 outlets to be able to clean this water and this water also. And if I take them both down at the bottom, I will have more expense. I will have to build one outlet here and another outlet there. But if I take the water out on the side, I would need to connect these 2 water outlets into one waistline, one only. Go out to the side and then fall onto the box of filters. And that would reduce this height of this table another 10 centimeters. So it would have to be only 30 centimeters high. Okay, I think that's all related to the design of the pool or aquarium. I hope you liked the video, and you'll come back to see the other chapters. Okay, if you like the video, please remember, give it a thumbs up and subscribe, and click on the bell if you want to be notified of the next chapters of this series. Well, thanks for watching, and bye-bye.